We all know how to differentiate a function. If I differentiate a function, I will call it first derivative. So the derivative we know is also called first derivative. If I differentiate first derivative, I will call it second derivative, and it will go so on. The idea is really simple. We can differentiate a function as many times as we want. We have common notations for this concept. First derivative, second derivative, third derivative, fourth, fifth, it goes on and on. The important one is the nth derivative, because in problems we will see we want to differentiate a function n times. It will ask us the nth derivative. Nth derivative is a formula, because if you find nth derivative of a function, you can plug in any number for n to figure out any derivative. Fifth derivative, sixth derivative, seventh derivative. So this is the formula for the nth derivative. First example, f of x is a function differentiated until derivative reaches 0. First derivative, 8x cubed minus 9x squared plus 5. Second derivative, 24x squared minus 18x, constant is gone. Third derivative, 48x minus 18. Fourth derivative, 48. And lastly, fifth derivative is 0. So this function reaches 0 at its fifth derivative. F of x is e to the 2x. What is nth derivative of this function? We need to differentiate this a couple of times until we recognize a pattern. Let's see. If I don't differentiate it, the function by itself is e to the 2x. If I differentiate it once, the n is here, the n I'm using is here. First derivative, it will be 2e to the 2x. Let's write our formula. For n is equal to 2, second derivative, I get, instead of 4, let me write 2 to the power of 2, 2 squared. Third derivative, instead of 8, let me write 2 to the third power, because I'm trying to recognize a pattern. There's a 2 to the 0 here, right? And there's 2 to the 1. So I should catch something. It should tell me something. You can go until you see it, and to the fourth power, and fourth derivative. That looks, that does not look like 4 at all. Okay. So this will be 2 to the fourth power, e to the 2x. It goes on and on. What do I get at my n? As we can see, for every n, the power of 2 also changes. And it's the same number of my derivatives. So therefore, the nth derivative will be 2 to the nth power multiplied with e to the 2x, because e to the 2x did not change. A really huge derivative example. Of course, we will not try to differentiate this 2001 times. That would take our life. What else can we do? First of all, we need to think it like this. The power is 2000, and the amount we need to, the derivative is 2000 first. Therefore, did I clean something? Okay, think it like this. If you were differentiating x squared, and the question is third derivative of this function, 2x, x, 0. If it was x cubed and you wanted to differentiate it, it was the fourth derivative, 3x squared, 6x, 6, 0. What should I understand from this? If the derivative, the power of the derivative, the nth derivative, is greater than the power of the function that I'm differentiated, this goes to 0. The derivative is 0. So 2002nd derivative is also 0. 2003rd derivative is also 0. It goes on and on. It's all 0 after 2000. What if it's equal to the power though? X to the 100. What is 100th derivative? Good question. Again, the number is too big. Let's think it like this. We want to differentiate x squared. What is the second power of it? First derivative is 2x. The second derivative is 2. X cubed. Third derivative of it. 3x squared, 6x, 6. X to the fourth power. What is fourth derivative? 4x cubed, 12x squared, 24x, 24. I need to realize something again. This is equal to 2 factorial. This is equal to 3 factorial. This is equal to 4 factorial. If you don't believe me, try to expand these and try x to the fifth power as well. See it by yourself. It will also be equal to fifth power at the fifth derivative. So therefore, 100th derivative of x to the 100 will be equal to 100 factorial. Last example, f of x is ln x is given. What is the nth derivative? Again, I need to recognize a pattern. For n is equal to 0, which means the base form, that I don't differentiate the function, ln x. First derivative now. What is derivative of ln x? 1 over x. Instead of, I will write that as x to the power of negative 1, because I will differentiate this again. What is the second derivative? Minus x to the power of negative 2. Let's differentiate it again. 2x to the power of negative 3. What is fourth derivative? Negative 6. Again, I am sensing some factorials, as you can see. 2 factorial, 3 factorial. Maybe the next one will be 4 factorial. Negative 6x to the power of minus 4. Fifth derivative. 24x, as I said, fourth factorial as a constant here to the power of negative 5. All right. From this, I need to figure out the nth derivative. If you cannot, you can keep going. It's all fine. But I think we can figure out from here. First of all, I need to see I have one positive, one negative, one positive, one negative, one positive, one negative, one positive, one negative. This tells me this derivative will start with minus 1 to the power of n plus 1. Because, for example, try to write 0, it's positive. Try to write 1, 1 plus 1, 2, square of a negative number. Positive. For 3, it will, and 2 plus 1, 3, it will be negative. So it should start with negative 1 to the power of n plus 1. Next step, these numbers, at these constants. As we said, we have some factorial here. This is 2 factorial. This is 3 factorial. This is 4 factorial. N is 5 when the factorial is 4. N is 4 when the factorial is 3. N is 3 when the factorial is 2. This is clearly n minus 1 factorial. The most important part is, what is the power of x? Let's see. When n is 4, power is minus 4. When n is 3, power is negative 3. When n is 2, power is negative 2. So therefore, the power is x to the power of minus n. Let's try to write in a cleaner form, we can write like n minus 1 factorial over n.